welcome everyone to our panel. I prepared one slide for the start.
30 seconds.
Okay. While Pablos is preparing for us kindly the slides, the one slide, let's make a round of introduction. Maybe let's start with in this way. Georgia.
Okay, hello. I'm Georgia Nicolakopoulou. I'm a team member of Future Needs. We are very glad to be here with all of you today, organizing the event, but also it's a great opportunity to discuss in person. So this is the most important for me. I'm an architect in my background, and I've been in EU projects as a communication and simulation manager for more than 5 years now. And well, this experience of EU projects, and some of them very related with technological advancements, is and urban planning today, is the reason that I'm very happy to be here and discuss with you.
Thank you, Georgia. Clara?
Clara Garcia Sanchez. I'm an associate professor at the University of Technology in the Faculty of Architecture and Built Environment in the Urban Data Science section at Urbanism Department. And my background is surprisingly aerospace engineering. But very early in my career, I decided I wanted to do environmental flows, so I specialized in urban flows with uncertainty quantification techniques. And in the last years, more how to make it the pipeline of urban flow simulations more accessible and fast.
Hello, thank you. I'm Yannick Hofmann. I am a media artist and researcher, currently working at the Fraunhofer Institute of Industrial Engineering. I'm having a 15 years track record of basically using artificial intelligence technologies for human-machine collaboration, and I'm basically employing these for such crude endeavors like developing an intelligent museum. So I did the Intelligent Museum project, as part of which we basically developed a digital twin for the museum domain.
Hello everyone, I'm Brian Gavin. I'm a senior lecturer in SAFE AI, University of Stuttgart, UK. And I'm more interested in how we use AI safely and avoid the risk of AI itself. We understand now that AI is like infrastructure of many applications, but if we will not be able to protect the infrastructure itself from adversarial AI attacks and make the AI trustworthy, and people can have high adoption of the AI, which can benefit the societies in general. Recently, I've got a project related to building anomaly detection in manufacturing, but with considering this safe AI and trustworthy AI in manufacturing, and which has potential, and we start collaboration with the finance sector as well, because it's based on many security incidents as well, and how AI can benefit
I'm Christophe Prudhomme. I'm a professor at the University of Strasbourg in applied mathematics. So I work on numerical methods, solving PDEs, working on methods to accelerate the solution, to solve PDEs, high performance computing, and then try to apply these methods to different topics. And today it's about environmental topics with exterior urban building. So I've worked for the last 4 years, 3 years, 4 years in HiDALGO2 on developing this platform, trying to put as much engineering as possible and being able to deploy in a large scale way on HPC machine what we are doing.
Thank you. I'm Kyriaki Daskalouthi, as I told you before. I'm a mathematician and I'm working in Future Needs as a project manager in HiDALGO2, as you can understand, but there are some aerospace projects, transportation projects that we're working on, and that is it from my side. I'm very excited to start the discussion, so I think you can go ahead and ask the first questions.
Okay, thank you. Let me start the discussion with Clara. Clara, as a member of the DET team, is a coordinator of a very...
No, I'm not coordinator.
But the DET University is the coordinator.
Yeah, DET University is
DET University is the coordinator of a very interesting project called Urban,
correct.
which is very similar to our project and maybe the other projects too that we have seen from Stuttgart just recently. Can you introduce us to that project, please, and tell us whether you can see some synergies? Let me tell one comment more that Clara is a member of our advisory board.
Yeah. So the project, indeed, there are some synergies that are potential to the project, and there are also some few differences. So the Human project came out from the European Union funding. It's an infrastructure funding, wanted to develop digital twins of the Earth. So it came up to life as the digital twin for the urban areas, and is focused on different goals. So air quality is one of them, indeed, and which is in similarity with the urban area that you presented today, right? But there's also other goals, like for example, extreme events like heat waves. And in that sense, there's a really large collaboration with higher fidelity models, which we saw a little bit less of that today. We saw a bit of the wildfires, and I believe there's some high fidelity there. But for the airplane, for example, it's not currently used, let's say. The operational models are ground space or meteorologically based. So that's kind of the separation, I would say, between what we saw today and a little bit what the Urban Air project is tackling. But indeed, the application is also to urban planning scopes, so it's also looking into how these could become part of the digital twins of the Earth, how these could be embedded into the destination Earth systems, which is a European effort, and how these could be used to do prevention decisions and planning decisions. So in that sense, I can see a lot of synergies from HiDALGO2 in that project.
Okay, thank you. Before going on with another question, let's have a look at the slide that I prepared. First, we have to discuss very shortly the definition of the digital twin, or what we understand under the digital twin, because there are several definitions are used in the literature, several definitions, and some of them are simply simulations, but we understand as digital twin, a digital replica of a real asset which is continuously connected to the real physical world by sensor measurements or with other data, but some data permanently informs the digital replica about the status of the real world. And the data are assimilated into the simulation model, if it is a simulation digital twin, and it's always live updated. And this is the main difference between the little bit older simulation technology and the digital twin technology. The online, dynamic, real-time update of the state of some sensor data or something. And I collected some information about the main technology developers. First I mentioned the destination Earth that was mentioned by Clara, that this is besides it's a good initiative coordinated by the ECMWF. It's scientifically one of the top scientific hub of the Europe or on the Earth. This is one of the main scientific hubs. On their websites, you can see many white papers on the state-of-the-art technologies to create digital twins. In particular, they are experts in data assimilation technologies. The second that I wrote here for industrial digital twins, it's Siemens. It is maybe one of the market leaders. The Siemens, you can see plenty of materials on their website, and also on YouTube you can see excellent interview with Norbert Gauss, the vice president. Excellent understanding. We can understand the digital teams plus the AI. We shall coming back to this topic with Tarek later in this panel discussion. So it is worth having a look at the Siemens materials. EUMETSI, the European Service Network of Mathematics for Industry and Innovation, is the maths technology platform in Europe which consists of 20 countries. And in the strategic research agenda, they collected all of the state-of-the-art of the technologies for digital twinning. For example, for the HPC related things are drafted by Uli Rüde from FAO, for example. So it's an excellent material for digital twinning sub-technologies. ETP for HPC drafted the real-time digital twinning white paper. By the way, it was drafted by Siemens as ETP for HPC contributor. I'd like to mention that while preparing to this panel, I found a very recently started journal which is called Digital Twins. This is planned to be a top journal, and it is worth reading the first journal of last year by Michael Greaves on the digital twinning technology. It is really worth reading that. So this is somehow that we can collect as digital twins. Clara and the team and the Urban Air project will develop a similar one embedded to the destination Earth infrastructure. Okay, thank you. We were already talking that Tarek will speak about that. Tarek, can you tell us something, please, about your experience of the Siemens digital twin, please?
Thank you, Sultan. As I mentioned, I'm working on a project for anomaly detection using AI. We not just using the traditional AI for this anomaly detection. We built the safe or secure AI and explainable AI in this anomaly detection. We targeting to make the AI safe from adversarial attacks or maybe robust adversarial attacks. So if adversarial attack could be similar to poisoning the data while training, so the decision of the AI will be based on unreliable data, so they give unreliable decisions, so having consequences as well. As well, we targeting to make the AI non-black box, or make it clear to non-expert people, non-technical people to understand why AI has recommended any recommendation, any decision. So make it easy for the non-technical people to trust the AI so they can start having, collaborating with AI as a part of the team. And then in a discussion with Siemens, because they using anomaly detection for industry and one of the leading companies for the industry. And we found that they are using AI inside the digital twin. So they build the digital twin with the traditional way, while making it more smart. So AI could then be mining and gain insight from the data collected in real time, and then make prediction and creating even number of scenarios which can be tested later as well. And then this could make the digital twin itself as a smart digital twin, not just replicating the real phenomena, and then can create scenarios for the simulation. So I looked at I had experience to test the digital twin itself, and we can see that they created scenario, detected the anomaly and the downtime. For example, I think they reported they saved around 85% of the downtime from the manufacturing. Well, they haven't deployed these security issues or considered security issues in their digital twin or AI digital twin. So this sort of correlation, and now looking at the next level, not just replicating what's already in the phenomenon, but making the digital twin as well create some prediction of the future. For example, in the traffic, for example, monitoring the air quality, they can see whether maybe after a couple of hours or the next few hours, the air quality could be affected by the traffic jam, so they can divert the traffic based on this prediction of the AI inside the digital twin itself.
Thank you. And Kyriaki?
I want to ask a question to Christoph, actually. Yeah. Between all of the things that we have said today, where does HPC make a decisive difference for urban planners, people that actually end users, etc.?
So here, as I mentioned earlier in the talk, I think the scale is important. We want to be able to screen fast and in a repeated way, reproducible way, the stock of buildings, and then watch the progress in terms of renovation, improvement. For example, in France, beginning of next year, they are going to change the conversion factor between the primary energy and the final energy. So in the model that they actually compute the energy performance certificates, there will be a change for many buildings, and so eventually people will have to, and a lot of people will be impacted by that decision. So policymakers will have eventually a lot of people will not be happy because they will have to make decisions about renovating their buildings. So with this kind of tool, you could screen entire cities, possibly an entire country, regularly, and watch the progress over time. Yeah. And before making the decision, you could also see in a more accurate way who's going to be impacted and where you need to make the best effort. Right? So to do that, you need HPC to be able to tackle this kind of problem. Another aspect, the fact that you have other type of technology like cloud computing and things like that. Now the problem of here we gather potentially a lot of data. Okay, in the end maybe we have aggregated metrics, simple metrics for the policymakers to make decisions, but still we need to have reproducibility, traceability, and so you need to store a lot of data, right? And so on the cloud, if you want to distribute this kind of computation, that may be problematic for performance. HPC systems here have the capabilities to handle large loads in terms of computation, as well as storage matter, things like that. So this is one possible answer. There are others.
Thank you very much.
Thank you. And the museum digital twin, what is it for? How much it is useful for you? Because you have maybe not a visual digital twin, but a very, very useful digital twin. How do you use it?
Well, a museum is a very different field, I would say, because you have basically the visitors, so you have the area where the people come, and for this it's very relevant also to think of prediction models which you can introduce to anticipate, for instance, the quantities of visitors for the museum staff to perfectly adapt to this. And for this, for instance, we developed then prediction models where we experimented a little bit with different kinds of data, like there is a movie theater across the street. So in how far does the movie program, for instance, affect whether some people will come and stuff like that. But then, of course, we also have many different fields of application which go more into the direction which you, Tarek, mentioned when you were talking about something like, I think, predictive maintenance and stuff like that, yeah? Because this is also very relevant if you detect anomalies. And for instance, in a media artistic installation, for instance, yeah, then you can immediately send out the museum technicians to repair things. But then we can also discuss aspects of automatizing aspects of the museum. But I'm not really talking about sensitive areas like where it's sensitive towards discrimination. I'm really talking about aspects of, okay, there are only 5 people in the museum space, so we can basically lower the volume of a sound installation, or we can basically dim the lights in order to reduce emissions and CO2 and whatever. So those were the aspects relevant to the intelligent museum as a technical apparatus. But the overall aim is always, and this is, I think, relevant to all of us, to enhance our human intelligence, to give us decision bases, to make informed decisions.
One use case of your museum digital twin is that you predict, for example, the number of visitors for the next days by AI, right? And do you rely on that? I mean, your boss, the boss of the museum, rely on the digital twin prediction?
No, but I'm here as a hybrid. I'm an artist and a researcher, so I can make experimentations to stimulate both discourse, but also new ways of thinking. But if you go away from the prediction model, but you go more into the direction of, okay, you have a sensor basically detecting, for instance, spoken language or something, and then you have digital interfaces adapting to the spoken language of foreign visitors, then all of a sudden you have an intelligent museum which adapts to the preferences of, to the needs of people. So there are many, many different ideas condensing into the intelligent museum, and I try to adapt a little bit. So I heard a little bit about anomaly detection and predictive maintenance stuff, so I thought maybe those were aspects you might be interested in, but I think the other aspects we brought in might be even more interesting, and I think we share more common ground than we actually expected initially.
Yeah, excellent idea and excellent job that you did this intelligent museum. Just I wanted to ask whether the non-experts, like the director of the museum, accepts the predictions and they say, your digital twin predicts that for tomorrow we have double the visitors than today, so more people will be invited to schedule it.
You know, for this we still need the executive summaries, the management summaries, so they will be given basically the summaries by the experts, like the digital managers who are working in the corresponding departments. But for now, they do not base their decisions solely on machine systems. I do not expect this. But I think that we see so much technological progress where we can actually enhance museum intelligence. I mean, think of all of those multi-agent systems and everything. Yeah, think of all of those different departments which might get amplified by this. Period.
Thank you. And Georgia, as architect, so you are not a developer of a digital twin. But how can you see the obstacles of using our professional digital twins that we created, or the ICT Stuttgart created digital twins as an architect? You see that the operation of a digital twin is maybe a little bit technical, or how can you see the applicability of the digital twins in real urban planning or architect's work?
Well, for me, it's, I mean, I'm not a technical person and I really cannot understand the technical details that you share with each other today as researchers in the field, but for me it's interesting what it brings to the end users, what can it bring for the citizens and what can it bring for the urban planners and designers in general. So examples that you have shared definitely help understand, and I think this is the challenge also for all of you, how to, for all of us actually, because as part of disseminating, as part of the EU projects, this is what we are called to do, to disseminate and communicate about the results, and showing the value of these advancements, technological advancements to the end users is one challenge. If we get them to understand that this is something that brings benefits to their daily routines, then this is the first step. So stakeholders from design area or the industry or citizens, simple citizens, understand is essential and see how this is part of the policies and the regulations that we have, how this will help them support their compliance with these policies. Because if this is an optional, a nice to have feature in design, then depends on how willing you are to invest in this effort. To get familiar with all the systems and the tools. And that's also a challenge, how this, which visualization was one question I had before when I was talking to what kind of visualizations and presentations to these stakeholders are really helpful to promote these tools to the end users. Maybe we can discuss this with experts and the people that have already been in touch with municipalities, have experience on that, and what is working well with that. Because for me as a designer, I must say that I find it difficult to interact with the visualizations I saw so far. So I have questions like, is the final report that we expect me as an urban planner, for example, to interact with and take input of, or something else, a dashboard or some other visualization. I think that professionals expect integrated tools with high usability integrated with their current tools. So designers should use building technologies, building tools, and urban planners use GIS, and maybe integrated tools with that would be highly acceptable.
I have an idea, and Marcin will decide on whether to accept it and the community. What about organizing a workshop or such that we provide, developers provide our tools, and non-experts come to our machines and try our tools, and to see, and we would be, I would be as a PI for the Urban project, I would be very glad to hear your opinion. And
I would be very glad to be part of that workshop, and I think other people, the communities would be also very glad. I strongly believe that that should be kind of a process for these research activities. I think Urban has that part in, we are happy to be also leading the dissemination in your project. So I know that you work with communities and stakeholders, and I don't know a lot about how is this going so far. but I'm very interested in knowing that. I think this is a good way to build trust with the involved parties and know more in advance on, validate what you do and create scenarios with them, validate data with them maybe. That would be an idea.
Okay, maybe we can put it as a work package 5.
Or the next project.
Package 6. No, we don't need, we had 1
We
year
have time
more.
with this one,
So
yeah, that
within
would be
this
nice.
HiDALGO2 we can make it, and everyone who is interested will be invited. We have a stakeholder, we have a user, Stockholm City. Actually, they are using our tools, but those guys are not relevant because at Stockholm City, the environment office, they are HPC guys or something like that, so they can run everything from CLI, command line interface. So that is not relevant. But an architect or urban planner, so everyone is invited who is interested to bring tools, and on the other hand, everyone who is present here at the meeting or see this recorded video, then we are organizing workshop in 2 months or somewhere. As we can schedule to the future. Okay.
Okay, maybe it would be important information, yeah, to everyone, because next year is the last year of the project, yeah, lifetime. It means that we are entering the specific phase of the project, putting into practice. Yeah, we promise to implement what we are doing, not only as a science, but something real. Yeah, the Stockholm is, of course, the perfect example, but we have signed a letter of interest with 4 cities, and we promise to deliver something. Something is this real feedback supported by the simulations, and it should be also attached with some explanation, because, for example, what is clear for the scientists like Zoltan, he presented a lot of screenshots, yeah, which could be very hard to read to the external people, for the policymakers, from the city hall, for example, right? So we need to also take into account their understanding and their needs. They need to have a clear feedback, what they need to do with their city, what it costs, and what precautions must be made in order to avoid some, potential dangers, yeah, in the city. So, okay, we are putting into the space. Probably first 6 months we will take this implementation. Second half of the year would be the perfect chance to collect this feedback, yeah? To present it in the sense of the simulations, in the analysis afterwards, which is understandable for the external people, and and they collect the feedback. Basically, this is what the reviewers of the project expect from us, yeah. So very good idea, but we need to locate perfectly in the time.
Okay, let's discuss it. The exact time. Okay, then let's go back a little bit to the technical parts. So the technical parts, Clara, we discussed also the resolution. What is really needed? What's your opinion? Do we need really, what's the role of GPUs, for example, to achieve the best resolution?
Yeah, so I'm not really expert in GPU side, but I know a little bit about resolution. My personal opinion is use the resolution that you need for your specific problem. If we think, for example, the example of wildfires is perfect, right? Because you have the meteorology fields feeding perfectly into the fire, which is something that is happening at the microscale range. So I think we really need to think what's the resolution that we need for the problem that we are trying to solve. If you're trying to do urban planning, then you want to have a higher resolution than if you're trying to see what's the meteorological conditions over the city. So those are 2 different problems to predict. And I think that's what we should be looking at. So in what we do, for example, we always ask, is this analysis going to go for the city level? Do we want to see a full city? Or we are interested in a specific area? That specific area then should have higher resolution than the full city.
but what you feed might become from a lower resolution. So I think, yeah, we could have different answers to this, but I think looking at the problem that you're trying to solve and the application can give you a little bit of the resolution. But of course, once you start using resources, then that's also another bottleneck that GPUs is helping us with, right? We can accelerate our simulations, but in the end, the resolution will determine the cost.
Okay, because on your website I saw that 100 to 1 meters is your target.
We go under 1 meter because
1 meter?
Yeah. For the run simulations, for example, we go under 1 meter. Because if you want to sample at 2 meters height for pedestrian, you want to have at least 3 points under, and we want to go lower than that. But those are highly detailed resolutions.
Okay, thanks. May I ask you, Tarek, about the risks of AI, especially when AI is coupled with the digital twins. Digital twins create a lot of data, and on top of that, we can use that as training data. What is the risk of that, and what is the trust of AI?
Thank you. Very good question. I think this is I mentioned this in the previous answer. Well, I think maybe looking at the risk there are could be categorized as privacy risks, especially I think we are using data from the citizens. If you are scanning, for example, the indoor air quality, you would need just to have the behavior of the user while using the ventilation or opening the windows and so on. This is now privacy risk of the data collected, and then the AI could mine this data, and it could be identification of the people based on their behavior in the city. So data should be somehow anonymized or using some techniques called the differential privacy, where they hide the behavior or de-anonymize the data before using it. Otherwise, as I said, I think the quality or the integrity of the data. Digital twins use real data to build this model or to update other models as well. If these data coming from the sensor are not genuine or falsified, so you are now poisoning the data, somehow it's called AI poisoning the data, and this leading to unreliable decisions as well. So the data, while collecting the data, we need to make sure that the data is genuine. If this is not possible as well, I think there are other techniques called the adversarial training. So the AI will be trained assuming that there will be adversarial or falsified data or not genuine data. And then in that case there are some techniques to isolate this falsified data or to recorrect or correct this data as well. Otherwise, even during the deployment or the operation of the predictor, whether this is in the digital twin or other tools, the attackers can manipulate the data such that to trick the AI to classify or to get the decision they want, not the data actually should lead to this decision itself. This is called evasion attacks as well during the operation of the AI. There are techniques as well to consider to isolate or detect these attacks and correct them. So these kind of security risks making the AI maybe the target, because I said it's the core of the infrastructures. I think we need to consider all these risks, especially for this kind of tools which will be used for big decisions which impact the not small community but maybe the country itself. So by poisoning or the data evasion, or sometimes even the what's called inversion of the model itself, so you can replace one technique with another. Well, it depends on the access to the model itself. So sometimes we need to make sure who have access to the model of the AI used, because all the models, they may have different outcome from different data. So there is no standard model will be used and giving the same accuracy of the results across all the applications. These are, I think, a few of the risks I think we need to consider, especially for these critical systems, I would believe. In addition, I think the trust as well, this is one of the risks as well. We are using AI as a black box. If it's not clear to the non-technical people, they may not trust in using AI itself. And they may be decision maker, they can take decision blindly, and they don't know what are the main reasons behind this decision itself, what the cause, the root causes for the phenomena. And this is what's called as well the transparency of AI or explainability of how the AI does such decisions. I think maybe considering these kind of risks would strengthen the decision maker on helping the planners as well to take better informed decisions.
Thank you, Tarek. Probably we have several topics to discuss. We have a limited time, but we still have time, a short time for comments from the panel or also from the audience. If anyone wants to comment or question. I have prepared a question to you.
Sorry. Regarding the previous point,
okay.
I mean, I made the point also during the talk. I think it's not only about AI, it's the entire tool chain that must be trusted. Right? So we need to have pipelines, security, inside, knowing exactly who has done what with what. Up to the AI. So this is critical, I think.
Does there exist standards for the workflows for the to ensure security? Does there exist standards for workflows?
Yeah. Yeah, I think this like authentication or access control. I think this is standard by NIST. The access control ISO 27001, where I think we need to manage who accessing what and when, and creating the privilege, who can access what at what time and what they have done to look all this data, so we can trace or to limit who's doing what as well.
Thank you, Tarek. In the break, I will write down the number and try to understand the standards. Not always happens that I understand the standards, but I hope that at this time. Anyone from the audience, a comment or question? One short. We have 2 minutes.
A very quick question. I think that it was a little remark about visualization. I think digital twins should have common strategies for visualization. Given that we have large extensions of territory with sparse data, barometric data, may suggest to join our efforts towards common strategy of visualization. Particularly today, it's taking forward the Gaussian splatting for over large areas. May suggest to explore together the use of Gaussian splatting for capturing and representing the reality, and on top of that, with the result of our models.
David, you're right. The problem is that when we are running on HPC and want to real-time visualization, this is really a challenge. There are other experts in the room, but these are really a challenge to get immediately or at a convenient time, realistic time, immediately, real time, visualize data from HPC. This is a real challenge, in my opinion. I cannot see, we have an offer for that solution, by the way. Anyone from the panel? Yes.
Well, based on what previously said, you said, Darren, about AI and how we can integrate that with digital twins. I wonder if, I don't know, the consortium of HiDALGO2 stuff, maybe you can also contribute to that. Do you think that integrating AI in the models that we have created in HiDALGO2 would make it easier for us to access the, to visualize the things or to interpret data that we have, information that we have from the content, from the models for the end users. Would that be some issue?
As far as I'm concerned, I think they are using AI. I'm not sure what is it in the digital tool itself or in other tools. But I would say maybe for the interpretation, I think this is called technically it's called explainable AI. How we can make AI non-black box, so like the play for the black box. How we can make the AI more easy for interpretation, so communication with the non-technical people. So for example, yes, AI now suggested that we need to switch on the air conditioner. So we need to see as a non-technical people based on what the factors, how are you considered to take this decision? Because maybe the sun will be, or there will be a high temperature after a few 2 hours or so. There will be some heating problem and whatever. So these decisions should be, I think, clearly communicated to non-technical people, and this is what explainable AI can help to do in this way. And I think could be applied in other contexts as well. So the explainability.
Thank you. Yes? One from the audience. Last. Okay, so since you mentioned the AI, are there synergies with AI factories between COEs? Is this something that has already started? I'm saying, yeah, AI factories. Yes. Are supposed to collaborate closely with COEs. Are we there? Is this something that's happening?
To my knowledge, for example, in France, we got the answer not so long ago about AI factories, so this is being built up. But definitely the connections are there from my point of view. Probably Denise was here some time ago. I'm sure that Marcin also has some answers. So I guess the connections are being made between the COEs and maybe it was not the question, I don't know.
No, it was a question. I'm just wondering, personally, I'm interested in synergies between COEs and AI factories. I'm representing the Cyprus Institute. Recently, we got an AI factory antenna connected with Pharos in Greece. One of the topics, two of the topics actually, which are strongly related to digital twins, are sustainability and digital cultural heritage. So, one of the things that we need to achieve is actually strong collaboration with COEs. So, I'm just wondering whether this is something that has already started.
Many partners of the HiDALGO are HPC centers, and we are hosting AI factories, like for example PSNC. We have a factory. Also, the factory is established here at the HLRS. It's also a partner to this project. So of course, at the moment, everything is under establishing all of these things. But looking at the core of the next release of the COEs, AI would be very much highlighted in the priorities, in the description. So all these aspects should be definitely highlighted. So probably the infrastructure will be ready for that at the beginning of 2027 when we start the next release. And of course we must be ready with some implementation. Some partially we have started already. On the different levels, starting from the simulation, through the data analytics and the visualization as well. So this AI is and of course the visible and present, but we need to probably highlight it by this different aspect, like the explainability of this AI, yeah, making it more secure in order to avoid this. Because honestly, so far we wrote the proposal for HiDALGO2, there was of course some question about data security, data violation. Zoltan is, for example, data ethics manager. We are trying to consistently monitor this data. But so far, data were for us something agnostic, yeah, to this, because we are using only the weather, information about the traffic, no personal data, no medical things, no like that. But after this discussion, we see that this is not only true from all angles. Yeah, we might see at the AI. Because there are aspects that even this data are agnostic to the violation, to the personal issues. There are different aspects like explainability and affecting the results of the AI. Because I suppose that in a few years people would ask why this decision is taken by AI and given to the people. Because they completely follow, yeah. Okay, because AI told us, yeah. It was like Google navigation, yeah. People drive in the cars to the lake because Google told them to go there, yeah. So of course this explainability is important. We need to ask questions: why, yeah, and it should be clearly provided, yeah. Because otherwise we would be only the foolish for the customers of the AI. I believe this is not the direction we want to go.
Thank you so much, and thank you for all the attendees coming for this panel, and in particular, many thanks for the panelists for the fruitful discussion.